Hello everyone, I'm Mohamed-Amine Babay. I am PhD student in Renewable Energy in Industrial Engineering Laboratory at University Sultan Moulay Slimane, especially in the Faculty of Science and Technique Beni Mellal. First of all, I will thank you for this opportunity that you give me to present my work, and also I will present my supervisor, Sir Mabrouki Mustapha. Without delay, I will start by revealing to you my work plan, exactly in study of the soil effects on PV plants performance and definition of the optimal cleaning protocol. As you say, as a plan, I have summary, introduction, problematic, experimentation and results, and finally conclusion. Many research and studies have been developed in order to increase the efficiency of the solar technology as photovoltaic. The PV panels are characterized with high transmittance factor to transmit the sunlight to the solar cells. The result of the study showed that soil accumulation on the surface has badly affected their efficiency and performance. The soil is the weakness spot of the solar plants. It badly affects the solar field performance, what leads to energetic and economic losses. Furthermore, to get rid of soil onto PV surface, ample quantity of water are required in addition to the suitable cleaning device for each technology. In what's follow, I will discuss first the device for soil measurements and factor affection, then the impacts of soil onto solar plants. Soiling mechanism on PV surface. Generation and deposition are two main phases that soiling goes through before each reach the solar panel surface. Then comes addition and removal. The following schema shows the life cycle of soiling particle, dust for example, from generation until removal. Effects of soiling on PV panels. First of all, measurement of soiling and to factor effects into soiling rates. Soiling deposition, such as aerosol or dust, can be measured using multiple devices. The most used are the tracking clearance sensor and the reflectometer for soiling rates and mirror reflectivity measurement for CSP plants and to current voltage curve tracer for PV application. Secondly, impact of soiling on solar plants. Many research and study were done in order to reveal the effects of soiling on photovoltaic panels. In fact, soiling can absorb an important part of the incident light, which affects the electrical performance of the solar cells. It causes a remarkable reduction in the transmittance coefficients on the PV panels. The study investigates showed clearly that the transmission coefficients loss rise when the dust density goes up due to time and weather condition. That means the dust prevents the photon energy to reach the solar cell. That's weaken to photovoltaic conversion. On the other hand, soil deposition on PV panels serve as a thermal barrier from the sun insulation, what leads them to be cooled several degrees. This cooling may increase the open circuit voltage, but it decreases the short circuit currents. The panel's surface clearness is related to soiling rates, which is dependent on weather data, wind speed, relative humidity, and wind direction. Research show that the faster the wind is, the cleaner surface are especially for the dry dust, but a high relative humidity level causes this particle to more likely stick on the panels and hardly removed by wind only, what makes soiling more severe on surface. Thus, many cleaning technologies have been invented to serve an efficient cleaning technical and economical. Actually, cleaning methods are divided into three main processes. First of all, hand-made cleaning, semi-automatic cleaning technology, and automatic cleaning technology. The analysis of the soil ratio variation necessitates to be joined to precipitation data. The reference soil ratio of the cleaning panel was taken equal to 0.9. The figure below represents the soil ratio variation and the precipitation during this period. As we say, from this graph, it can be clearly noticed that the soil ratio for the non-cleaning panel has reduced from 0.97 on the first month July to 0.6 into August, which signify a reduction of 20% of the electrical output. Well, for the weekly cleaned panel, solar has not really affected to electrical output. On to August or September, the solar ratio increased with 10% due to rainy days, what refer to an increase into electrical outputs. Then is start to decrease linearly when no watching occurs. The daily average drop into solar ratio for the non-cleaned panel is about 0.13% from July to August. This difference between two periods can be explained by rain that acts as a natural cleaner. Furthermore, to emphasize the role of the rain, an amount of precipitation of 0.4 millimeters was recorded at 2 September or 0.7 millimeter, where the soil ratio has significantly increased to reach to value 0.9, which means a gain of 70% into electrical output. From this investigation, we can conclude that the weekly client panel showed satisfying results in terms of electrical outputs during all this period in comparison with the non-cleaned one, where the short current widely diminished. The results showed that high cleaning frequency is very efficient in terms of energetic gain, but it is very costly, hence the need to find a compromise between the cleaning frequency and the economic gain. In large solar plants, it is necessary to adopt automatic cleaning device to reduce the cleaning cost in terms of water consumption and labor cost. Furthermore, during the winter, where the precipitation are important sometimes, it is recommended to cancel the cleaning schedule if the mirror or panel are already cleaned naturally by the rain.